Hello, geometry students. Welcome back here. We're looking at section 4.5 today, isosceles and equilateral triangles. Let's go ahead and go over the vocabulary, which you've already done before you hit play on the video. Number one, an equilateral triangle has two or three congruent sides. Equilateral triangle has three congruent sides. An equilateral triangle has acute or obtuse angles. Those are all going to be acute. Circle the equilateral triangle. That would be this guy right here. Okay. Isosceles is our word for the day. A triangle is isosceles if it has two congruent sides. All right. So these are examples of isosceles figures. This is an isosceles triangle. This is an isosceles trapezoid. The angles and sides of isosceles triangles have special relationships. We're going to look at that today. Use the triangle below. Write a letter in each triangle in the correct circle at the right. All right, which one of these looks equilateral? That's going to be D. Which one are isosceles? So isosceles means they have two congruent sides. All right, well, A does, B does, D does. It has two. Just so happens it also has three, but it has two. So the definition of isosceles triangle it would be at least two congruent sides. It's okay to have three. And then the last one in there will also be E. All right, and which one of them are right triangles? All right, well, A is a right triangle and C is a right triangle. Theorem 4.3, 4.4, and 4.5. The isosceles triangle theorem. The isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. All right? So what that means, is if I have an isosceles triangle, then that tells me that I have two congruent angles as well. All right? So that's what the isosceles triangle theorem says. All right? If I have two congruent sides, then I have two congruent angles. And now what angles are those going to be? All right? Well, if these are my two sides that are congruent, then these are the two angles. And they're the angles that are opposite the congruent sides. All right? They're the ones that are opposite the congruent sides. Okay? The converse of that says, just flip it around. The converse says, if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So the other way is that if I have a triangle where I know two angles are congruent, then that tells me the two sides have to be congruent. Okay? So that's what an isosceles triangle is. You can either determine its isosceles from knowing two sides are congruent or from knowing two angles are congruent. All right? Because of theorem 4.3 and its converse, theorem 4.4. All right? Okay, so once again, if I have an isosceles triangle, the angle that is opposite this side and the angle that is opposite this congruent side, those are the angles that are congruent to each other. All right? Now, if we look at this figure right here, this is going to show us some vocabulary and how we talk about isosceles triangles. All right? The two sides that are congruent to each other we call legs. The odd side out, the one that is not congruent to the other two, we call that the base of an isosceles triangle. So that means we call the two congruent angles, we call those base angles. And then the odd angle out, the one that's not congruent to the other two, we call that a vertex angle. All right? Theorem 4.5 says, if a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. All right? Okay, so let's think about what that one says. If segment PQ is congruent to segment RQ and triangle PQR, all right, then what angles are congruent? All right, so let's take a look at the triangle. And it says that segment PQ is congruent to segment RQ. So what angles are going to have to be congruent? P and angle Y. All right. Underline a correct theorem number to complete the sentence. The theorem illustrated below is which theorem? Oh, that's going to be theorem 4-5. All right. So let's talk about 4-5. How does theorem 4-5 work? All right. So what it says is that if we bisect the vertex angle of an isosceles triangle, so this is an isosceles triangle, and I bisect the vertex angle. So those two angles are congruent right there. Then it's also going to perpendicularly bisect the base. All right. So I'm gonna know a whole bunch of congruent pieces. All right. That's what that theorem says. All right. Using the isosceles triangle theorem, is angle WVS congruent to angle S? Is segment TR congruent to segment TS? Explain. All right. So the markings show that segment WV is congruent to segment WS. Is angle WVS congruent to angle S? Explain. All right. So let's look at it. We're looking at this little triangle right there. All right. And we're given these two segments are congruent. If those two segments are congruent, then those two angles have to be congruent. It's that simple. All right. So yes. All right. Why? Because of the isosceles triangle theorem. All right. Because of the isosceles triangle theorem. Okay. Is angle R congruent to angle S? Is angle R congruent to angle S? Yes. All right. Yes, it is. So if we look at this figure, we now know through a little bit of a transitive property, right? So yes. All right. All we need to do is use transitive. Okay. And what we did is we have transitive property through these two angles here are given as congruent, angle R and angle WVS, because they have tick marks. And then we just show that angle WVS and angle S are congruent. All right, so that means by transitive, angle R and angle S have to be congruent. All right, so let's write that one out. So we said angle R is congruent to angle WVS, and then angle WVS is congruent to angle S. So angle R is congruent to angle S. Well, now in this big triangle, if angle R and angle S are congruent to each other, right? If these are congruent to each other here, then that means that these segments have to be congruent to each other as well, right? Segment TR and segment TS. So that would be yes. Why? Right? By the isosceles triangle converse. All right? The converse is the one that says if the angles are congruent, then the sides are. The theorem says if the sides are, then the angles are. All right, so make sure you understand the difference between them. All right, go ahead and pause the video and try this one on your own. All right, let's look at part A. It says, first off, what do we know from the given information? We got a bunch of tick marks over there. Is segment AB congruent to segment CB? And that is a big old yes. All right, yes. Why? By the isosceles triangle converse. Because what I have in this big triangle right here, we have these two angles congruent. Those are the base angles. So that means that the side opposite them and the side opposite that one are congruent, which are segment AB and segment CB. Right? So yes, by the isosceles triangle converse. All right. Next, is angle A congruent to angle DEA? All right? And my answer would be yes. Okay, because now if we look at the little triangle, this little triangle right here, the tick marks tell us these are congruent. So that means these two angles have to be by the isosceles triangle theorem. Okay, so again, make sure you understand what direction you're going. If I'm given the sides are congruent, then I know the angles. Or if I'm given the angles congruent, then I know the sides. All right? What's the difference between those? One's the theorem, one's the converse. The theorem says, given sides, I know the angles. The converse says, given angles, I know the sides. All right, let's go ahead and look at problem number 2 here. Problem number 2, we're going to use some algebra. Suppose the measure of angle A is equal to 27. What is the value of x? Well, since segment CB is congruent to segment AB, the tick marks show that, we know we have an isosceles triangle. All right, so this whole triangle right here, that is isosceles. All right. Since triangle ABC is isosceles, the measure of angle A is equal to the measure of angle C. All right, which is going to be 27. So these are both 27 degrees. Since segment BD bisects the vertex angle, as you notice right here, these little tick marks in here show that this segment BD is bisecting that angle right there, angle ABC, the vertex angle. All right? So that means that I have perpendicular right there. So there's a right angle, and it also means it bisects the base as well. So those two pieces, segment AD is congruent to segment CD. All right? So we know that segment BD is perpendicular to segment AC, and the measure of angle BDC is equal to 90. All right? So that means in this triangle right here, I know 2 of my 3 angles. I know that the measure of angle C plus the measure of angle BDC plus x equals 180. Well, that's going to be, measure of angle C is 27. The measure of angle BDC is 90. X, my unknown, and add those together, it's going to be 180. That's going to give me 117 plus x equals 180. Subtract 117 the other side, and I get 63. So x is going to be equal to 63. Okay? All right. Try this one on your own. What is the value of x? Pause the video. Okay, let's take a look at this problem here. So this angle A is the one that's given as 54 degrees, which means this angle is also 54 degrees because in this giant triangle right here, the big one, it's isosceles. So those 2 angles, angle A and angle C, are congruent because they're the base angles of an isosceles triangle. All right. So also what's happening is this angle is being bisected right there. All right. So that's going to create perpendiculars. Right. That's going to create perpendicular right there, or a 90-degree angle. So this triangle right here, I know 2 of the 3 angles. I know 90 and 54, and x has to equal 180. So that's 144 plus x equals 180. Subtract 144, and x is going to give me 36. All right. So a little bubble practice here. 36 is how that works there. Okay. All right. A corollary is a theorem that can be proved easily using another theorem. Since a corollary is a theorem, you can use it as a reason to prove. So what a corollary is, a corollary correlates to a previously known theorem. A correlation means there's some kind of relationship, right? So a corollary has a relationship to a theorem that we already know. And usually what that corollary is, it's such an easy and obvious theorem, we kind of downgrade it a little bit and just call it a corollary. So technically it is a theorem, but it's not a huge, profound statement, a theorem that's going to change lives. All right? It's just a simple theorem that can be concluded from a previously known theorem. So it's a theorem that correlates to a previously known theorem, so we just call it a corollary. But it is a theorem, all right? So corollary to theorem 4.3 and 4.4. It says, corollary 4.3 says, if a triangle is equilateral, then the triangle is equiangular, all right? So if it's equilateral, meaning all three sides are the same, then that means all three angles are the same. So this is equilateral, this is equiangular, all right? So that's what that means, okay? And you can see that the corollary, why this is a corollary, because it's just very similar to the isosceles triangle theorem. Now I just add in the third side and the third angle to make it equilateral and equiangular, that's it. All right, and the corollary to the converse of the isosceles triangle theorem says something very similar. It says that if a triangle is equiangular, then it's also equilateral. So it works both ways. If you know all the sides are the same, then you know all the angles are the same. Other way around, if you know all the angles are the same, then you know all the sides are the same. All right? And again, you can see how this is very, very similar to the converse of the isosceles triangle theorem. If I know two angles, then I know two sides. But now if I know three angles, then I know three sides. So identify the correct number to complete the sentence. The corollary illustrated below is corollary to the theorem what? All right, which theorem it shows? Well, that one shows 4.3. All the sides are the same implies all the angles are the same. Okay? Finding the angle measure. Suppose the triangle at the right are isosceles triangles, where the measure of angle ADE and DEC and ECB are vertex angles. All right? So that means that these angle ADE, that angle right there, angle DEC, that angle there, and angle ECB there are all vertex angles. If the vertex angles all have a measure of 58, what are the measure of angle A and the measure of angle BCD? Okay, so which triangles are congruent by side angle side? So you can see that we have three triangles congruent by side angle side, right? We'll have triangle ADE congruent to triangle DEC, which is also congruent to triangle ECB. Which angles are congruent by that isosceles triangle theorem? Right? Well, in this triangle, it's going to be angle A congruent to angle DEA. In this triangle, it's going to be angle EDC congruent to angle ECD. And in this triangle, it's going to be angle CEB congruent to angle B. All right. So the angles I'm looking at again are those and those, those and those, those and those. All right. That's what we're looking at. So by the triangle angle sum theorem, the measure of angle A plus 58 plus the measure of angle DEA has to equal 180. Right? Has to equal 180. So now we're just going to solve for the measure of angle A. All right? Let's just complete the algebra. Okay? So, I know that these two angles are the same, right? So we can call that x plus 58 plus x equals 180. X plus x gives me 2x plus 58 equals 180. Subtract 58 to the other side, and I get 2x is equal to 122. Divide by 2, and I'll get x is equal to 61. All right? So since angle A is equal to the measure of angle ECD, the measure of angle ECD is also equal to 61. All right? All right, now it says to find the measure of angle ECD. All right? The measure of angle, BCD. So the measure of angle BCD, that's this angle. So what that means I need to do is I need to add these two parts. I need to add this angle plus this angle. And that's going to give you the whole thing. All right? Well, we know each one of those measures already. So we'll just add those parts together. The measure of angle BCD is going to equal to 58 plus the measure of angle ECD. All right? So that's going to be 58 plus 61, which is going to give us 119. Okay? All right. All right, go ahead and pause the video and try this one on your own. This time, instead of being isosceles triangles, notice all these triangles are now equilateral. All right, problem 3. What are the measures of angle A, angle B, and angle ADC in the photo at the right? Okay, so if we look, we're going to let A equal the measure of one angle. All right? Well, each one of these angles here inside these triangles, these angles here, here, and here, there, there, and there, 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 and there, all have to be the same because it's equiangular. So they're all going to be 60. So the measure of angle A equals the measure of angle B, which is going to be 60. The measure of angle ADC is equal to the measure of angle ADE plus the measure of angle CDE. All right, so what are we trying to find? All right, that's going to be the measure of angle ADC. That's right here. So I'm going to have to add this part and this part, which is going to be 60 plus 60, which will give us 120. Okay? All right. Pause the video, go ahead and do the lesson check. Okay, let's take a look. What is the relationship between the sides and angles of each triangle, each type of triangle? Isosceles and equilateral. Complete here. Number 22. An isosceles triangle has 2 congruent sides. An equilateral triangle has 3 congruent sides. Complete each statement with congruent isosceles or equilateral. The isosceles triangle theorem states that the angles opposite the congruent sides are congruent. Equilateral triangles are also isosceles. The sides and angles of a equilateral triangle are congruent. Okay? All right? So remember, to be an isosceles triangle, all it needs is 2 congruent sides. Could it have 3? Yes. But all it needs is at least 2. Okay? All right. What's a corollary again? A corollary is a theorem that's not quite theorem worthy to have that title. All right. So it's a theorem, but it's a theorem that can be proven way too easy to be considered just a regular old theorem. It correlates to a previously known theorem. The legs of an isosceles triangle. So if we have an isosceles triangle right here, the legs are the two congruent sides. Those are the legs. The base of an isosceles triangle, that's the odd one out, right? That's the base. The vertex angle of an isosceles triangle, all right? That's the vertex angle. That's the one that's not congruent to the other two, all right? And then the base angles, those are the congruent ones. Okay, all right. Any questions with that? A dot and how well you understood of today's lesson on isosceles and equilateral triangles, and you're all set to do the assignment for 4.5. See you next time.